Here's a continuation of determining whether they are functions or not. So again, when we have a graph, our easiest thing to do is to use the vertical line test. So I'm going to produce a vertical line and test whether our vertical line here, whether it crosses more than one point at a time. So we get to this first set right here. I'm going to pause. So if we notice, we have a dot, a dot, and a dot. So all of these are crossing the vertical line at once, which would tell us right away that this is not a function, because that is saying that -2, about -2, +3, these aren't exact, but -2, -1, and -2, -4. Again, those aren't exact because they're a little bit off on the graph. But if we notice that this vertical line test is saying that each of these inputs is producing different outputs, which makes it not a function. All right, the next one we have here, let me get another vertical line. If we have a vertical line here, and let's test it. So if I were to drag it across my thing, we notice that, drag it across the graph, that it is only touching one part of the graph at once, which would mean that this is a function. All right, now we have a set of x and y values, and we're going to check whether it is a function or not. So we have a 2 and a 4, a 2 and a 5, a 2 and a 6, and a 2 and a 7. So right off the bat, that should spark your attention that we have all 2s across the x values, which are the same input, but each of our outputs is different. We have all of these different outputs that are being produced. So this is not a function. On our next one here, we have a 0 and a 0, a 3 and a -1, a -5, -5, and a 4 and a 0. So each of our inputs is producing different outputs, so this makes it a function. All right, moving to this next one. We have 3s all the way across on our inputs. So unless each of the y's was the same, this is not going to be a function because each of these are different. So this is going to be not a function. So we have 0, 4, 7, 6, and so this is where people might get confused, is because all of our inputs are different, but our outputs are all the same. So let me just So I'm going to take these points right here, and I'm going to just plot them on this graph just for a visual. So I have 0, 4, 1, 4, 7, 7. Oh, I'm not doing that right. Sorry. 0, 1, 4, 1, 7, 1, and 6, 1. So if I were to do a vertical line test if I were to take my vertical line and try it on the ones that I just plotted from this example, we notice that all of this would pass the vertical line test. So this is a function. All right, the next one here, we have 2, 5, 8, and 1, and those are all different, so we're going to have a function. All right, we have another graph where we can test with the vertical line test. So if I take my vertical line and drag it across, I'm going to pause right here, and we see there's a point here, here, and here. So this is not a function. Let's take another vertical line test for our next graph. So if I pause it at each of the dots, I notice that there's only, in this case, there's only one coordinate point. So this is there's only one coordinate point crossing through our vertical line at once. All right, this bottom section, we have 5, 5, 4, 4, 3, 3, and 2, 2. So all of our inputs are different, so this is a function. And our last one, we have 0, 2, 0, 4, 0, 6, and 0, 8. So if we notice, each of our inputs is the same, but all of our outputs are different. So that creates a problem, which means it is not a function. And I'm going to go ahead and just plot, even if I plot the first 2 points, so I'm going to take these 2 points. So if I did, I'm going to just plot them up here just for over 0 up 2 will give me, so if I had over 0 up 2 and over 0 up 1, 2, 3, 3, 4, my vertical line test that I use to remember is passing through both of those red dots. So that would fail it, and that's another way you can assume function or not.